A change in one variable is associated with a change in the other variable in the opposite direction. With a single value, you can able to understand the relationship. So that kind of measuring technique of correlation is called as Karl-Pearson's coefficient of correlation. If R is equal to 0, then the two variables are uncorrelated. Hello everybody, I'm Divya, lecturing with Vidhyaashram Pre-University College, Mysuru, the Temple of Excellence. I extend a warm welcome to you all for session 2 on your correlation chapter 6. Moving forward, meaning of correlation, properties of correlation coefficient techniques, and the problems on Karl-Pearson's coefficient of correlation. So these are the topics that we are discussing in today's class. Moving forward, let us understand what is Karl-Pearson's coefficient of correlation is all about. So in the last class, we have discussed about the scatter diagram. So it is only the plotting the points and finding out the direction. So it does not give the appropriate relationship between the variables. So numerical calculation wasn't there in your scatter diagram, but here in this you will be completely solving the problem by using Karl-Pearson's coefficient of correlation formula and understand the relationship. So let us understand what is Karl-Pearson's coefficient of correlation. So you will be able to know how the relationship will be varied and how based on the numerical value the relationship can be explained. So Karl-Pearson's coefficient of correlation is also called as product moment correlation. So here you will multiply the relationship between x and y variables. So by multiplying the values you will get the answer. That is why it is called as product moment correlation coefficient or simple correlation coefficient. It gives a precise numerical value just based on a single value. The number, the decimal, you will be able to understand what kind of relationship it exists, whether it is a positive relationship or a negative relationship. So with a simple value, with a single value, you can able to understand the relationship. So that kind of measuring technique of correlation is called as Karl-Pearson's coefficient of correlation. It gives a precise numerical value of the degree of linear relationship between the variables, that is your x and the y variable. So it explains the relationship. So let us understand more about Karl-Pearson's coefficient of correlation. So it is important to know that Karl-Pearson's, so he was a statistician and he has given the formula. So coefficient of correlation should be used only when there is a linear relationship between the variables. So when the Karl-Pearson's coefficient correlation should be used when there is a linear relationship. Okay. So to begin with, when there is a correlations or when there is a non-linear relationship between x and y variable, then calculating Karl-Pearson's coefficient can be misleading. So the only condition that is there to use the Karl-Pearson's coefficient of correlation is that so there should be a linear relationship between your x and the y variable. So non-linear. So if you use for non-linear calculation, the answer will be misleading. So what are the properties of coefficient of correlation? If you don't understand the properties of Karl-Pearson's coefficient of correlation, you don't understand the problem. So let us look at the properties of Karl-Pearson's coefficient of correlation one by one. So R, so this is represented symbolically as R. So R has no unit. It is a pure number. It is just a number. So it means unit of measurement are not part of R. So R is just a number. So that is symbolically represent coefficient of correlation symbolically represented as R, and which is a pure number. That is the first and the most important property of Karl-Pearson's coefficient of correlation. Next is a negative value of R indicates the inverse relationship. So R is equal to +1 or R is equal to -1. So it ranges between +1 or -1. So if we have -1, so then it will be what? It will show the negative correlation. So a negative value, minus value, when you calculate the values, if you get the minus value at the end, so that explains what? Inverse relationship. So inverse relationship is nothing but a negative correlation. A change in one variable is associated with a change in the other variable in the opposite direction. So it is negative correlation. So if R is positive, then the two variables move in the same direction. So if R is +1, that is positive correlation. Moving forward, the value of correlation coefficient lies between -1 to +1. As I have told you, my dear students, -1 lesser or equal to R, lesser or equal to 1. So what is this? It lies between -1 to +1. So if any exercise, the value of R is outside this range. So in any of your problem, if you take up R and if you calculate the data in any of the exercises, if you get the value more than this, outside this range, it indicates the error in the calculation. So whatever the R you get, it will be either -1 or +1. So within this range only the answer will be there. So -1 or +1. So it will not exceed more than this. So if it exceeds the number, the calculation is wrong. So the magnitude of R is unaffected by the change of origin or change of scale. So irrespective of your multiplication or division, so it is unaffected. The origin and the value is nothing but dividing and multiplication. So that doesn't affect your correlation. So given two variables X and Y, let us define the new variable. So by understanding this, you will be able to know what is correlation, how the correlation will be. So it ranges between -1 to +1. So it should be the value what you calculate should be within this number itself. So if it exceeds, the problem is wrong. Moving forward, let us understand more properties about your correlation coefficient. If R is equal to 0, then the two variables are uncorrelated. So there is no relationship at all. So if R is equal to 0, then there is no relationship between the variables. So there is no linear relationship between the variables. If R is 1 or R is equal to -1, the correlation is perfect and there is exact relation. So what is this linear relation? You must be wondering, ma'am, you're using linear word. So what is the linear word? So if it should be what? Within the R is equal to 1 or R is equal to -1. The range should be within that only. So then it is perfect and the linear relationship. If R is 0, then it is non-linear relationship. So high value of R indicates strong linear relationship and its value is said to be high when it is close to +1 or -1. So if it is R is +1, so it ranges between your 1, so then it will be strong linear relationship. So if the low value you get close to 0, 0.44, 0.6, 0.2, so 0.5, so if it ranges between that, so then it shows the weak linear relation, but there may be non-linear relationship as well. So R is equal to 0 also will be existed. So R is equal to 0 also might happen. So that is what? That is your non-linear relationship. Moving forward, test yourself. So it's nothing but your problem. So let us take up the problem and check out your Karl Pearson's coefficient of correlation. Before reading the question, let us look into the formula. So what is Karl Pearson's coefficient formula? R is equal to, N stands for number of observation, sigma dx dy. D stands for deviation. So you know, to take up assumed mean, we use assumed mean or actual mean method. Take up the assumed mean or actual mean and then calculate the deviation. So that will be our D. So dx dy minus sigma dx into sigma dy divided by root number of observations sigma dx square minus sigma dx whole square into, so wherever this is there, it is nothing but your multiplication into. So again root n number of observation, this is sigma again. So dy square minus sigma dy whole square. So this is how you calculate. This is the formula. So let us solve the problem, understand the question. So kindly go to the formula once again and understand. So number of observations sigma dx dy minus sigma dx into, this is into. In between into should come. So sigma dx into dy divided by whole root, that is number of observations sigma dx square minus sigma dx whole square into again root n number of observation dy square minus sigma dy whole square. You'll get the answer. So let us understand the question, what is given in the problem. So calculate the correlation coefficient between height of a father in inches x and the height of their son, that is represented in y. So x and y 65, 66, 57, 67, 68, 69, 70, 72. It is nothing but inches. It is represented in inches. So y 67, 56, 65, 68, 72, 72, 69 and 75. So x is given, y is given. With the help of this, we have to solve the problem. So this is the column. So calculation of Carl Pearson's coefficient of correlation between the height of a father and the height of a son. So x column will write it. The next column is dx. So what is the first step to be followed? First step is calculation of actual mean. So what is this actual mean? To find out this assumed mean, or you can also take it as actual mean. So what is the, how to calculate that actual mean? Sigma x divided by n. So how to calculate for y actual mean? Say sigma y divided by n. So what is given? X is given, the summation of x. So what you people have to do? Write down the data of x. The summation of x will be sigma x. So what is this? Sigma x. So sigma x will be how much? 535. So next what you people have to do? Write down y column and summation of y will be sigma y and it is 540. So what is the number of observation we have? 1, 2, 3, 4, 5, 6, 7, 8. So number of observation is how much? 8. So 8 is the number of observation. So 8 is the number of observation. So n is what? N is 8. So let us calculate this sigma x. So what is sigma x? That is 535. So 535 divided by 8. It will be around 66.875. So 66.875, we will take approximately actual mean as 67. And moving forward, we'll calculate for y. And what is y? Summation of y, that is 540. So 540 divided by 8, it will be 67.5. So almost it is 67 only. So we are taking y 67.5. So we are taking actual mean as 68. So now let us calculate the further. So dx. So how to calculate dx? To find out, so what is given in the formula? N we know. Sigma dx dy we doesn't know. Sigma dx dy. To find out this deviation only, we have calculate the assumed mean, that is your actual mean. So what is the actual mean? How to compute actual mean? Sigma x divided by n, sigma y divided by n, actual mean. So we have calculated the actual mean to find out the deviation itself. So let us find out the deviation for x. So what is the actual mean? 67. So 67 minus 65, it is how much? Minus 2. Next 67 minus 66 minus 1. 57, 67 minus 57 minus 10. 67 minus 67, 0. 67 minus 68, it is 1. So 69 minus 67, 2. So 70 minus 67, 3. So 72, 67, 72 minus 67 is how much? 5. So this is how you calculate. So what is dx? 65 minus 67, it will be minus 2. 66 minus 67, it will be minus 1. 57 minus 67, it will be minus 10. 67 minus 67, 0. 68 minus 67, it is 1. So your x minus a. What you have to do? X minus a. So 65 minus 67 minus 2. So like that only you have to do it for all the things, and the summation of dx will be minus 2. So how it is minus 2? 1 plus 2 plus 3 plus 5. You have to subtract from minus 10, minus 1, minus 2. So you will get it as sigma dx is how much? Minus 2. So how to calculate deviation? X minus a. Next column, next thing you have to calculate is dx square. So what we want? We want x square, deviation x square. So that is why we are calculating what? Dx square. So 2 2s are 4. So minus into minus, it will be plus. So plus 4. Minus into minus, plus 1 1s are 1. 10 into 10, it is 100, minus into minus, plus 100, 1, 2 2s are 4, 3 3s are 9, 5 5s are 25. The total of sigma dx square will be 144. The summation of the whole calculation of dx square will be how much? 144. Next, we have to do same thing for y. We have calculated the actual mean. So dy. So how to calculate x minus a? So x is how much? 67. 67 minus 68. How much it is? Minus 1. Greater number sign, minus. So 67 minus 68. How much it is? Minus 1. So 56. Minus 68, minus 12, 65 minus 68, minus 3, 68 minus 68, 0, 72 minus 68, 4. So if you do for all, sigma dy will be how much? Minus 4. So next, dy square, the multiplication of dy. 1 into 1, 1, minus into minus, plus. So 12 12s are 144, minus into minus, plus. 3 3s are 9, minus into minus, plus. And here 0, 4 4s are 16, 4 4s are 16, 1 1s are 1, 3 3s are 9. The summation of the total of dy square will be how much? 196. Next, we have dx dy. So how to calculate dx dy? So dx is how much? This column. Dy is how much? This column. So you will multiply dx into dy. So 2 1s are 2, minus into minus, plus. 1 12s are 12, minus into minus, plus. 10 3s are 30, minus into minus, plus. 0 0s are 0, 1 4s are 4, 2 4s are 8, 3 1s are 3, 5, 3s are 15. So the total of dx dy will be how much? 74. So we have got all the values. So let us substitute the values to the formula and check out the answer. So what is given? Number of observation is 8. Next, sigma dx dy is how much? 74. How much it is? Sigma dx is how, dx dy is how much? 74. Next, minus sigma dx, minus 2 it is. So minus 2 into sigma dy is how much? Sigma dy is minus 4. Minus 4 divided by root. Number of observation 8. Sigma dx square is how much? Sigma dx square 144. So you must be very careful with the sign, because minus and the plus sign you have to multiply here. It is very important to look at the sign. So minus sigma dx. So what is sigma dx? Minus 2. Minus 2 whole square. Next, number of observation 8. So what is sigma dy square? 196 minus, what is your sigma y? Sigma y is how much? Minus 4 whole square. Minus 4 whole square. So now let us substitute the values and check out the answers. 8 into 74, it is 592. Minus 4 2s are 8, minus into minus plus. 4 2s are how much? It is 4 1s are 4, 4 2s are 8, minus into minus plus 8. Divided by 2 2s are 4. 2 2s are 4 and 4 2s are 8. 2 2s are 4, 4 4s are 16. 8 144 minus 2 2s are 4. Minus into minus plus into 4 4s are 16. Minus into minus plus. Next, now let us solve the bracket part first again. 592 minus 8. 584. Divided by 8 into 144. 1152. 8 into 144 is how much? 1152 minus 4. It is 1148. If you take up the root, it will be 33.882. Minus. So this is into. So into 8 into 196. It is 1568 minus 16. If you remove the root, 8 into 196 minus 16, it is 1552. If you take up the root, it will be 39.39. 39.39. So let us multiply that. So 1584 divided by 33.882 into 39.39. The answer will be 1334.6. So if you divide the answer 584 divided by 1334.6, the answer will be 0.437. So we can round it off as 0.44. So what will be the answer? 0.44 is your R. So what kind of relationship we have? We have positive correlation between the height of a father and the height of the son. This is 0.44 is the answer for this solution. The calculation of Karl-Pearson's coefficient correlation. So that's it for today's class. Hope the class was very interesting and you have learnt about the problem about how to solve the correlation coefficient. So in the next class, we will solve another technique, that is your Spearman rank correlation coefficient, and understand how the problem should be solved. So this correlation is very important for your examination. Thank you so much once again for joining for today's class. A smile is the biggest jewel you can wear. Keep smiling, people. Thank you.